In a previous video, we fitted a model to the Stumplift data. The data included polynomial terms for all three machines, and now we explore whether that model seems to fit to the data. Detailed explanation about model fit can be shown in this example here, but we just take a look at the graphs. The example also includes the R scripts that can be used for the production of the plots, as well as some examples about how these lagged correlation plots can be produced. First, we want to see whether the systematic part of the model is properly formulated. So then, therefore, we plotted the residuals on machine and diameter. Because machine is a categorical predictor, R automatically produces a box plot of that, and in that plot we don't see any problem. Actually, there cannot be any problem because we have separate models for all machines. Then if we look the mean of residuals with respect to diameter, we cannot see any trend. I am using this kind of whiskers plot here to help the interpretation, so I have classified the data in 10 classes so that each class includes approximately same number of observations, and then I have computed the mean of every class, and it is now shown by these dots here, and then I have computed the standard deviation of observations within that class, and especially for this purpose useful is the standard error of mean in every single class, and based on the standard error of the mean I have produced this 95% confidence interval, which is shown in the thick part of the vertical lines here, and this graph has been implemented in LM4 package in function myWhiskers, and it also highlights all classes where the mean is significantly different from 0 if we are using 95% confidence limit. So in this case we have two lines that are red, but otherwise the trend in the means over the range of diameter is quite nice, so we conclude that there are not any very big differences in the big problems in the systematic part. Here I have the same graph so that I have fitted value on the x-axis. We end up to the same conclusion, so it seems that the systematic part has been properly formulated. So then we can take a look at the random part. So first look whether the variance seems to be constant. So what we see here, if we look at the width of the boxes for machines, it seems that the variance for machine 2 and 3 is higher than for machine 1. We also see that the variability of the residuals increases as a function of diameter here. So we have this kind of megaphone shape for the graph. And we see the same phenomena also when we plot the residuals with respect to fitted values. So this length of these thin lines here can be used to explore. So it helps in interpretation, which is useful especially in this kind of data set where there are not very many high values, high number of observations with high fitted value, and the observations are mostly centered somewhere here. So the conclusion here is that the assumption about the constant variance among residual errors may not be or is not met in this dataset. And then let's look at the autocorrelation plot of the residuals. So these stumps have been lifted in certain order, and for example the working conditions in the location of the machine may affect there, or maybe the driver can be speaking a phone, or he or she can be getting more tired, so at some time she is processing more slowly, and some other cases time he is processing more efficiently, so probably there is some temporal or correlation among the observations. And that has been explored here using the lagged residual plot. And what we see here, we see that for shorter lags we have some correlation that is above the level of significance. So for lags from 1 to 5 we probably have some positive autocorrelation in the residuals, which indicates that probably we could also include some model for the temporal autocorrelation among residuals. But anyway, this autocorrelation is rather weak, so it might not be necessary, but for if you really want to do a very good model, I think you would like to do that. And when we explore these graphs, we see that there might be some influential observations, so maybe the stumps with a very high diameter can have more effect on the behavior of the curve than the other ones. And also the highest residuals are here, but they are not somehow very far from the point cloud, so probably they are not that influential ones. But before we can do more analysis, for example, look at the normality of residuals, we first need to fix the problems in the variance and covariance, because exploring the normality before doing that is not, or it is not wise. It doesn't tell actually anything.